Hi, Ben.
Hello.
I am really excited to chat to you today about a few things regarding electric twin. So we'll just roll through some questions. Can you tell me what's electric twin in one sentence?
Electric Twin is a company that builds synthetic audiences. Synthetic audiences are artificial models of real world audiences, and it means that companies can ask whatever questions they want and get answers in seconds rather than waiting for weeks.
That's really exciting. And can you tell me a bit more about how does electric twin actually work?
Electric Twin works by using a combination of, well, science, maths, most AI, so the bleeding edge models that sit behind the workplace assistants that you might use, ChatGPT, Claude, etc. Data, and then conventional data science and signal processing. So all that maths, all that technology is really designed just to try and make the most accurate possible model of a real world audience. So as a business, you can trust it that when you ask a question, it's as close as possible to how that real world audience would respond.
What's the role of seed data in electric twin? What does that enable?
In electric twin, we often talk about seed data. And what we mean by that is data that's actually on your audience. And the real reason you need that is to make sure that you anchor your predictions to the real world. Otherwise, what happens is you end up stereotyping or missing the uncertainty or the noise. Because humans, or every audience, no audience is perfectly the same. No brand has exclusively 27-year-old people who live in London. Everyone, there's a noise, there's a distribution. And if you don't capture that, you're not actually capturing the company's real customers. And therefore, you give inaccurate predictions. And it's very easy to make wrong predictions. The hard part is making right predictions.
And talk to me a little bit more about the stereotyping that large language models might do.
It's really interesting because often people ask us why, could I just do this in ChatGPT or Gemini? And the first thing I'd say is, if you just typed out 1,000 prompts and then added them all together and put them in a spreadsheet, it would take you ages. But also the worst part about that is after you've gone through that process that might take you 4 or 5 hours, it'll give you a wrong answer. And the reason for that is that these workplace assistants are designed to be really helpful for you when you're writing an email. If you ask it, what's the best way to write this email? You don't want it to come back with 30 options, some which are a bit weird. But if you ask, how will this group of people respond? Actually, you do need all those different 30 answers, including the weird people. And so if you use ChatGPT or Gemini to ask this question, it will give you a stereotype. So if you ask, say, for instance, 55-year-old northern woman without a degree, it will say Morrison's, they shop at. But if you switch it to degree, it will just suddenly say Sainsbury's. Actually, if you then add conservative voter on, it just switches to Waitrose, which is, really sort of like almost like a pastiche of somebody sort of just picking stuff out of the air. But that's because that's what they're designed to do, because that's how they enable you to write long essays, code, etc. Whereas for electric twin, what we're trying to do is not just assume that stereotypes are true and actually represent a real world audience so that companies can trust those decisions.
Does that enable you to see a broader spectrum or more nuance in the data? Because stereotypes might be quite good if I want a quick answer, but not if I want a complete answer. Yeah. Or is that wrong?
It's actually really interesting. So I think that people often overlook how useful, let's say, heuristics are rather than stereotypes, because actually, that's how the human brain works. Often we see something, we react to the pattern, and we move fast. The reason for that is obviously if you're human on the plains in Africa or in a jungle and you see something that looks like a tiger or a lion, it's better to start running now and then realize it's not than stay still and be like, wait, let me just check. But where that sort of falls apart is that it doesn't actually allow you to make really good decisions. That actually does is it basically just reinforces your gut feelings rather than making a data based decision. And so what you're trying to do is represent the accuracy of the audience, not just on the things that we sort of cotton onto, age, gender, but actually on the things that are more important. It might be income. It might be how much they care about the environment. It might be just what they like doing in the morning. Let's say, for instance, you're selling a breakfast cereal. It might not be gender the most important. It might be, do they eat breakfast, which is the much more important question. And so you want to be able to base your audience on the things that matter, not on the things that we just talk about a lot.
Talk to me about the methodology, sort of in very simple terms, and what's the part that's different, how electric twin has put the different pieces together.
Yeah, it's a really interesting question. And obviously, one of the things that is really interesting about synthetic audiences is there is no one method for creating them. There are lots of different methods. We have tried a huge number of different ones, and almost all of them don't work. All of them fail for different reasons. So if you look at academic papers in this area, they often use a similar method, which is essentially to try and as richly as possible describe somebody and then ask how that person would react to a question and then sum up all those answers. And what happens there is you get a very concentrated result. So let's just say you ask people on a scale of 1 to 5, how much do you care about the environment? Let's say most people say 4. Well, you'll get like 95% 4, but everything else you won't get the long tails. And so Electric Twin, what we're trying to do is we're trying to actually accurately represent that distribution, have the people who don't care about the environment and feel like it, especially for something like that that's becoming polarized. You see this group of people who sort of are not necessarily because they don't care about the environment, because they're basically saying, I am not part of that tribe. You have the people who are saying, I am part of that tribe, and then you have the people in the middle. So it creates this sort of triple hump distribution. And trying to represent that is about trying to make sure that your engine can accurately understand all those different factors, bring them together, and then create that noise, noise is a physics term. Most people would just call it the distribution. But that's what you're trying to do. And that's where the sort of like a lot of our work in Electric Twin comes from. And it's a combination of constructing together the different AI models in different ways at different levels. So not just at the individual level, but thinking about other levels like group behavior and things like this. And then thinking about not just the science of AI, but actual science. Well, I don't suppose actual science might be a bit rude to AI, given how good it is. But things like signal processing and other factors, more traditional, shall we say, statistical approaches, because all of this just helps us to push closer and closer to the real world distributions.
So it is about getting that distribution right. That's the sort of core essence of it.
That's in simple, very simple. Electric Twin, if it accurately predicts the world, it's an incredibly valuable tool to a company. If it doesn't accurately predict the world,
it's not.
It's not. And so we spend all our time and effort trying to make sure that we can accurately predict the real world and then show businesses that, because I think it's really important that we can demonstrate that, we can build that trust, because, if you're asking somebody to make a decision, it's really important that we help them to trust it.
Absolutely. What do synthetic audiences enable?
I think synthetic audiences finally allow us to move from a world where research is a sort of side function to one where it can sit on the really important decision pathways. When I was in number 10 during COVID, it was really interesting that you can basically write policy. So, what the plan should be around pubs early closing. You can basically do it overnight, but you can't do analysis overnight. So essentially, what happens is that the analyst isn't in the room because they can't work fast enough to be valuable, and then researchers, they feed data to analysts, so they're 8 weeks. So what essentially happens is often because researchers can't solve the problem in time, they're almost shifted off to the side. Whereas by using tools like Electric Twin, actually researchers can be in the room, and it means the voice of the customer can be in the room for companies. And I think that's the most important thing. The other thing it allows is just scale. It just means that in most businesses, if you talk to most insights teams, what they see, what they find is that actually they can't satisfy all the requests. They'll talk about maybe being able to satisfy about 10%, sometimes even lower. And this allows them to solve that problem. But it's bigger than that, because if you're spending most of your time trying to work out which of the 10 requests you should actually solve, that uses up a huge amount of your time. So if you can suddenly solve all requests, suddenly you actually are gaining back time. You're serving the business, you're gaining more value, you can scale. And so it moves it from this sort of doom loop of you spend more time working out what you should prioritize than working, to a really positive feedback cycle where as you solve more problems, the business gets more value. You get your ability to solve problems goes up, and so you start having this much more positive experience.
Before you were explaining to me the sort of what sits at the core engine at Electric Twin. We speak a lot about the role of social science and behavioral science. Explain that a bit to me and the importance of that.
It's interesting because obviously Electric Twin, we're both behavioral science. It's both we don't use it at all and use it a lot. And the reason why that sounds a bit odd is because 50% of behavioral science doesn't reproduce. Actually, in terms of science, we're not great at it. But there are some really interesting theories coming through that seem to be able to predict the world, the main one being cultural evolution. And this is the idea that you can think of this as culture being like the software that runs on our minds, and that allows us to make decisions, and that's how we make decisions. And so different cultures make different decisions. And Michael Murakrishna, who's the science advisor for Electric Twin, who's a professor at London School of Economics and NYU, he's one of the leading world experts in this idea. And so when we're thinking about Electric Twin, often what we're really thinking about is how do we find that cultural layer? How do we build that cultural layer? Because that actually allows us to predict. So you can think of it as almost Electric Twin is trying to sort of reconstruct the cultural software that runs in a human. And then if we have that software, we can then predict how the person will react, because we're just, running it through the same software to get the same answer.
And in this field of synthetic audiences, that was a new idea a few years ago that, it's gaining momentum. Are we the only ones using this approach? Are we sort of at the forefront? Are others are using it? What's the difference there?
I mean, it's hard to say. I think that most people believe behavioral science is better than we do. I think that most academics study the individual and think about the individual a lot. It's a very Western way of thinking about the world. If you look at, actually one of the reasons why behavioral science doesn't reproduce as well is because actually a lot of the experiments are done on American college students. And actually it turns out American culture is the outlier rather than the average. And so you can almost sort of like draw a line back from America, UK, Europe, from individual, and then you go towards the collective cultures of Asia. And so it's interesting that when you look at how scientists are trying to solve synthetic audiences, we're actually seeing their cultural software play out in their decisions of how they build around agents, what they believe is the right way to build it. And so, we're always looking to see how different ways we can build it, how are different ways that we can construct our tooling to try and best represent all humans, because actually, we're not just about individuals. We're actually it's about this group behavior as well.
Talk to me a little bit about accuracy. So that's sort of the most important thing. If it's not accurate, it's useless, right? How does Electric Twin ensure the accuracy of our results?
Well, we carry out a huge amount of experiments, both when we're building out our tools, but also to make sure that our tools are still accurate. And we really do two major ways of testing. One is where we take a set of data, let's say you've got a survey with 40 questions in it, holding out 5 of them, and then creating a synthetic audience with using that other 35 as the seed data for the synthetic audience. And then we can test the synthetic audience on the 5 questions we held out, which means we can see exactly how the real world answers and how the synthetic audience answered. And that's a really good test, because a lot of the time, if you're an insights researcher working in a large company, the question you're asking is very much like one extra on the survey. So it's a really good way of testing how accurate our software is in the real world as our users are using it. And then the second way that we test is through running very large scale experiments where we are really trying to sort of push the engine as far as it goes. So as an example of that, we did 7 identical surveys across a range of methods. And we pre-registered the predictions from the Electric Twin engine. We did this in collaboration with Michael, our science advisor at Electric Twin. And then we looked at how accurate Electric Twin's results are when you compare them to the traditional methods. And you can basically see that Electric Twin sits within that noise, that we are on a similar accuracy. Obviously, it's very hard to say what actually the real world looks like, because if you ask people, how you're going to vote, we do surveys, but actually then we actually do an election, and that's how we judge it. Whereas for things like, how often are you using AI? Most of your good friends are online or in real? Where do you shop? These are actual just questions that we don't necessarily have as a sort of definitive line that we can judge against. And that type of testing in the real world, I think, is really powerful because it's really going to the gold standard of social science to prove that we are actually a tool that can be used to understand humans.
We want to be able to replicate results, right? They have to be consistent over time, based on the real world. So when you run the same questions through a traditional method and a synthetic audiences, do any differences show up? And if so, which?
Yeah, you will. So if you run the same survey twice, you'll get a different result. There's a combination of reasons for that. One is you're asking different people. And the second is quite often when people are doing a traditional survey, I think sometimes we're unfair to them. It's like people say they're just clicking randomly. Actually, it's more just they don't care about the answer. Like if you say on a scale of 1 to 10, how much do I care about Nike? The answer is
not very much.
No, I mean, I'm sort of ambivalent to it. Like, so let's say I click 7. Well, tomorrow maybe I'm wearing Nike shoes, or I see you're wearing Adidas. Maybe that influences me and I click 6. And actually we can see this because we sometimes put the same question into the same survey twice and see how people change. And so in traditional surveys, you've got all these different factors that are playing out constantly. That's why it's really hard to work out what the real world error is of a traditional survey, because you'd actually have to run the same survey probably actually something like 200 times to get an accurate answer. Whereas with a synthetic audience, because we have the ability to run it exactly the same, if we do exactly the same thing in a computer, we'll get the same answer every time. And so this ability of a synthetic audience to actually be a reproducible experiment environment is why actually a lot of academics are really excited about how this could be used as a tool to help them when they're thinking about social science experiments and some of the work they're doing. Because in social science, you can't do experiments. In physics, you can. In social science, you can't. Until now, where synthetic audience might give you this sandbox that you can, build that confidence and build up ideas much more quickly.
Does it mean then that synthetic audiences are actually more accurate than humans?
I think right now, we have no evidence to suggest that synthetic audiences are more accurate than traditional methods. However, I think because of the ability to combine different information sources and data sources, and then the fact that you can test and evaluate a lot, and lastly, that gives you reasons why you might think that traditional synthetic audiences could become more accurate. And I think the major reason why I'm quite confident that will be true over the next years is because surveys are not that accurate. And the reason for that is most humans don't really know why they do stuff. And this is often referred to the say-do gap. They say they're going to do something, but they actually don't. So if you look at, say, for instance, asking people whether they'll vote, not very predictive. The most predictive way of find out somebody's vote is just ask them, have you voted before? Yeah. So if you voted in the last election, you're likely to vote. And that's why turnout modelling is really hard. But that's because people are really bad at predicting what they're going to do. Whereas synthetic audiences, suddenly we don't have to completely rely on what people say they'll do, which is what you have to do in a survey. You can start building in behavioural data. And I think that is that's why I think over time they will become more accurate. But right now, I think that would be, I don't think we have evidence to prove that.
Is there anything to say around, like, does the accuracy of a synthetic audience change as you dig deeper, ask it more questions, or because of what you've explained, it actually stays the same?
Well, right now, when we're judging synthetic audiences, often we're judging against the accuracies of surveys. Now, surveys are weighted to a nationally representative audience. But if that does not mean they have a nationally representative number of males in them, or females, or young people, that's not how the algorithm works. So as surveys, if you want to look at just the men in a survey, your error of that survey goes up. And so as you go to smaller and smaller sample sizes in the survey, the errors go up and up. And so actually it becomes very hard for us to, as our ruler becomes more and more inaccurate, it becomes hard to say your accuracy is going up or down. What we do seem to see is that the levels of accuracy that we have mimic the levels of accuracy we'd expect in the survey, given this sort of like the ruler getting worse.
Yeah.
But we're currently working on lots of different ways that we can try and explore different ways of measuring different rulers, working with companies about how we can use their internal data, things like this to really start thinking about how electric twin and our audiences can be more accurate than those methods.
Tell me a little bit about why you're building electric twin. What was the moment that kind of gave you the impetus to do something about what the problem you saw?
I was a physicist, and I was going to go out to the US to learn and do quantum computing. And I went down to my brother's company to learn a bit about AI, because we thought it was going to be important and useful for my physics career. And there I discovered sort of problems around human behavior, which I found more interesting than physics. And so I've worked for a decade in human behavior, but for the real thing about electric twin and why it's so important that companies have this ability to ask questions really fast, actually around the critical decisions at the scale they need, is because of my experiences in COVID. I think a lot of people think that the decisions around the big decisions in COVID, they would hope that somewhere there's a door, and behind the door there's like the ninjas with their models and their supercomputers. But that door doesn't exist in government. That door doesn't actually exist in any big company. We actually got the big companies, Microsoft, Facebook, Palantir, etc., into number 10. And the Prime Minister asked them and said, look, if you've got tools around human behavior, if you've got these tools, please let us know, because this is the time we need it. And they didn't. They, talked about the tools that they have publicly. We all know about. There aren't,
Facebook.
There isn't a hidden tool. Yeah. So when it comes down to it, there isn't this Minority Report style dashboard. What there is pictures on the internet that showed the actual way that I talked the Prime Minister through the decision about why we had to change strategy, which is a whiteboard. And the history of COVID, and I think that, where the decisions, where mistakes happened, etc., is something that needs further exposition. But it's really about our inability to understand and predict human behavior, whether that's bringing in policies that have the right impact on the progression of the pandemic, or trying to bring in policies that have that impact on the pandemic and minimize the other impacts, on mental health, on economic harms, all these type of things. And we just didn't have that. And so it was essentially just sort of like a discussion between, rather than a scientific discussion. And that's where I think electric twin can be really powerful, in that it starts helping everyone make better decisions. Because actually, COVID is an example of a massive decision where, extra evidence would have mattered. Lots of businesses are making, for them, similar scale decisions. But there's lots of decisions that we just have to guess because we just don't have the speed, we don't have the capacity to solve them. And so I just think if you can improve every single little decision in a business, overall that business does so much better.
And did you have a moment when you realized it was now scientifically possible to build what you wanted to build?
Actually, it's an interesting one. So I had this idea that it might work. And so I was over in San Francisco talking to Anthropic. And I asked Jack Clark, one of the co-founders, whether he thought this was possible. And he was sort of chatting and he thought it was kind of possible. And then actually he sent me a couple of days later, he said, "Oh, Ben, I came across this paper on silicon sampling, which showed the sort of potential for this to exist." And that's sort of like where sometimes when people talk about silicon sample comes from that paper. From potential possibility to actually being able to accurately predict decisions for companies, to actually predict audiences for companies, that has been a long journey. But there's always been this idea that large language models fundamentally are built on the data of the internet. Most of the data is not people writing business cases or code. It's people talking their thoughts, their beliefs, their emotions. So the idea that large language models somehow encode the sort of human experience makes sense and feels right. And then it's just being able to draw that large language model, that information into the right way so you make accurate predictions, rather than if you use Gemini, which isn't designed to do that, or ChatGPT, it's just designed to be your workplace assistant, then you get wrong answers.
What's the single most common question you get about reliability from customers?
I'll give two answers because I've got a good story and I'll see if it works. So when our customers talk to us, I think that they're always just trying to see, does it work? Is it accurate? And I think this is completely okay. Indeed, I think that sometimes we play a bit nice. Like, why would you not ask somebody that? In fact, I was once talking to an old Cambridge professor, and he was saying how he always tests things. And he said, and I was asking him, what's an example? Thinking he was going to give me a physics example. And he said, I was interviewing some kids to position in Cambridge, and this kid came in who, should we say, is a bit round, and on it he was a champion long jumper. So I opened my door, drew a line on the floor, and said, "If you make it past this line, I'll let you in." He didn't make it past the line, didn't get in. And I actually sort of, I've told that story to a couple of customers, and I sometimes think to myself, I don't mind if they say, let's jump. Like, I think, I'm making bold claims. Okay. They say to us, okay, here's the line. If you get over it, you're in. Fine. Let's do it. Like, I think that actually that is completely fine. We're saying this is how well our engineering works. In these circumstances, this is what it does. And they say, prove it. And we prove it. And I think that builds trust. I don't think that this idea that you should, just because it says AI and, AI, and why does that matter? We've had AI for a large number of times. We haven't been able to predict human behavior with AI for ever. So why now suddenly should companies trust it? And so that's where I think, that's why I think it's really important that companies actually do test it. Indeed, I actually think one of the points that makes electric twin that companies underappreciate is every one of our customers tests it. Every time we jump through those hoops, we prove it with them. But also every time it's deployed, we have lots of users using it every day, testing it, and then looking at other sources of information just to see if it's right. That's how everyone works, right? We look at one piece of data, we compare. So every day, electric twin is testing in our science team, in our validations with customers, in pilots, etc. But all our users are testing every single day. And every time they're making decisions and successful decisions off the back of electric twin, that's further validation that electric twin actually does work in the real world. And I think those sort of stories are really powerful for when we're talking to customers about trust.
Is there a criticism of synthetic audiences that you take seriously?
I think science is always about taking criticism seriously. I think that the most important thing, though, is that we always have to remember that electric twin we have a unique way of building synthetic audiences. And therefore, I think it's really important that a criticism of synthetic audiences can be true if you use one methodology, which we often don't use because that criticism is true. I think the one that really we need to make sure that we're always cognizant of is the ones around different cultures. Michael, who's our science advisor, is an expert in cultural evolution. And this is the idea that people have a software that runs in their mind, and that sort of software is how they make a lot of decisions. Now, he actually has done a lot of the work that shows that sort of cultural software is different in the USA to Europe to say, for instance, China, or a culture that's more collectivism. So actually what that means is that we have to be really careful that when we're building out our engine, that we don't accidentally force a certain cultural software onto a group of people who don't have that. So we're actually always testing that. We've actually tested against every country in the world using electric twin, and we've seen that it is accurate. But as we keep improving, as we keep looking forward to becoming more accurate, I think those type of things, being really aware of how different cultures think about different things and where their values align and disalign, is something we've got to be really cautious of, because otherwise I think what we end up doing is giving a false impression of how a certain group of people might react.
And is there going to be a moment where a large language model, say ChatGPT, catches up in terms of accuracy to, say, a specialist software like electric twin? So
I think if you'd have asked me in 2023, would we be here with large language models today where they can do what they can do? I would have probably said yes, but that's only because I sort of know humans are really bad at exponentials, but I wouldn't have really believed it. I wouldn't have believed that they could do, especially the stuff that they can do around code now. It's incredible. It's really, really really valuable, really important. So I think we should always remember that humans are really bad at judging exponentials. Actually, the story of COVID as well. But the interesting thing where the large language models have really, really improved is code. That's where they're really good. But what they can do, right, is you can write code, and then you can see if that code runs and does it produce the result you want. So you can sort of test and learn really quickly in a sort of sandbox environment. You can't do that for human behavior. You can't be like, okay, I think humans care a lot about AI, but then you've got to actually go out and try and find out if humans do care about AI. And that validation is really hard. And actually, one of the reasons for I think that the large language models providers will struggle with that is because actually a lot of companies hold that in private data. And they're not going to be like to the large language provider, yeah, sure, have my customer data. I mean, imagine if you're Netflix and you're like, okay, OpenAI, here's all the data on people care about or what they watch. And so sort of Now TV or HBO can be like, brilliant. Now we can make predictions. They're just not going to do that. This is incredibly valuable data that the companies possess. So they actually want to stop it getting into the large language models rather than enabling it. And so for those reasons, and then I think the last thing that why these models likely won't is because they're trying to build them to be amazing workplace assistants. They're trying to build, not the, from, I feel like at the moment they're the super smart graduate student who's really good, but sometimes does some batshit crazy stuff. And they're slowly working up the scale to better and better and better. But if you think about what the best possible employee looks like, it doesn't look like the most accurate employee. If your large language model was like, I'm a bit tired, I think I'm going to go home at 5 o'clock today, you'd be like, what the hell? But that's how people get tired. People have other things that go on in their lives. And when you're trying to predict how somebody somebody cares about stuff or how they're going to react, it's really important that you're thinking about the whole self of the human, not just them sort of when they're sort of sitting in their seat, pretend as the worker, rather than the sort of person who might, they might go to church, they might run scouts, they might, these might be the reasons they're going home. It's not, not everyone goes home at 5 o'clock just because they're lazy. They actually have things that they value more, and that I think they don't want to represent.
Describe quickly what it's like to work at Electric Twin.
Incredibly fun. We are very, very lucky to have really great people who are really talented. And then we're also lucky to have a really hard, interesting problem. I think the combination of those two things means that every day there's a purpose to what you're doing. And then the people who you're working with really sort of challenge you to be better. So it's a really enjoyable environment. I think it's a great place to learn, to develop. And then it's nice to be part of a company that's doing well. I feel like success is an enjoyable place to be, and I think we've got to work really hard to make sure that we maintain that success, that we keep trying to make sure that we keep the trust of the customers we're working with and the customers that we'll be working with. But it's really nice to work with such great people who are so passionate.
Excellent. Thank you so much.
Pleasure.